Hey everyone, welcome back. And today we'll be doing another Leetcode problem, another linked list problem also. 109 converts sorted list to a binary search tree. This is medium one. Given the head of the singly linked list where elements are sorted in ascending order, convert it into a height balanced binary search tree. What is a height balanced binary tree? A height balanced binary tree is defined as a binary tree in which the depth of the two subtrees of every node never differ by one. So there are difference between the depth from the node to the left or node to the right, or a subtree you can say, of each node um, doesn't differ more than one. So if we have a 10 here, you can say if there was not a 5 here, then this is also a binary balanced binary tree by height. But if there is not a 9 here, this 9 and 5 does not exist, then this is not a height balanced binary tree. We have to convert it into a height balanced binary tree, and that's it. Tree problems can be easily solved with recursion, and there is a good thing for us that the linked list is sorted. So what we can do is just call the function recursively to find the midpoint again and again, and then make the nodes of the binary search tree, obviously. And what is a binary search tree? So the root value, if we encounter a value that is less than the root value, it is going to the left, and it is going to the right if we encounter a greater value or equal value to the root value. So that's it. So for our exit condition, we will have, like, if there is not a head, then we will just return none. And also if there is a single node, if not head dot next, then we will just return by making a tree node passing it head dot val. Okay, so what we will be doing here is making three pointers: a previous pointer, a slow pointer, and a fast pointer. Previous will be none, fast will be starting from the head, and so the slow pointer. So while fast and fast dot next is not null, because we will be hitting two pointers at a time by fast. If you know how fast and slow pointers work, we use this algorithm to find the midpoint of the linked list. Previous will be behind slow, so previous will be equal to slow, and slow will be equal to slow dot next, and fast dot next. Okay, so after this we can see that our root value is going to be the tree node, passing it the slow value because the slow will be at the middle, and the values which are going to be on the left will be passing to the left of side of the function, and right to the right, obviously. So slow dot val will be making it the root, and root dot left is going to be self dot sorted binary search tree. Sorted binary search tree. uh, okay, passing it slow dot next because we already made a node with slow dot val, and we'll be passing slow dot next, and root dot right. Slow dot left will be passed to right side, yes, and this will be for the left side. And now we'll be doing the same here, but passing the head to the left side, and slow dot next to the right side. And after that we can just return the root, but we have to also remove the link from previous because previous is pointing to slow. So previous dot next shall be equal to none. So that's it. Let's submit it and see if this works or not. This works. And what is happening here, if we have a linked list like this, let me just write it down: 10 minus 3 minus 3 is 0 and 5 and 9. Okay, so we have our fast pointer at head and a slow pointer at head, and our previous will be somewhere like it is none, it doesn't matter where we put it. And when we hit our this loop will start executing because fast is ordinal and fast.next is also ordinal. So previous will be at the position wherever safe is, and safe will be incremented by one pointer and fast will be incrementing by two pointers because it is dot next. And again the loop will execute again because fast is not null, fast.next is not null. Previous is going to be at the position of slow, and slow will be incremented one time, fast will be incremented two times because it is dot next. And now fast dot next is not null, so the loop will not execute this time. Now if we can see, our slow pointer is at the middle. We know that whenever we have a slow pointer at the middle, then the values to the left of it are going to be less than it, as you can see, because this is a sorted list in ascending order, and so does the right side does have the higher values and the greater values. So what we will be doing, to the left side we will be passing the values that are the first half of the linked list, which will be just passed by if we give the head. But the problem here is that previous dot next, which was before slow, is also pointing to slow. So what we'll be doing is just breaking this node and saying that previous dot next points to nothing. So in that way we can just pass the left side to the first half of the linked list to the left side of the function, and if we want to pass the right side, then obviously we can do the slow dot next, which will be pointing to 5 and 9, and 5 and 9 will be passed down to the right side, and that's it.